Yes. Yeah. Sorry? Mm-hmm. 72. Right. Alright, so guys, the last thing we have to do for 6.4 is complex fractions. I already made you guys do a couple of these last section, so there shouldn't be that unfamiliar to you. So what a complex fraction is when you have a fraction built inside of another fraction. All right, so there's two ways that you can do this. All right, so you can, instead of having, what you'll see is you'll have, like in your denominator, you'll have one fraction plus another fraction. What you can do is try and make that one single fraction and then perform the division. Or what you can do is multiply by a common denominator and then simplify. All right, so we want to do number 4 two different ways. All right, so the first way I want to do it is I want to simplify the numerator or denominator first. All right, so what I want to do here is I want to try and put these two fractions together to make one single term. Right? So common denominator between those two would be what? 12, right? So that's going to give me 5 over 12 over all right, so if I change the first one, 2/3, that is 8. And then 1/4 would be 3/4. Right. Okay. All right, so now that they have a common denominator, you can put them together, right? So you have 5 over 12 divided by 11 over 12, right? All right, and we saw this last section, right? So when you have a fraction being divided by a fraction, you're multiplying by its reciprocal, right? So you have 5 over 12 times 12 over 11. So your answer is 5 over 11. Because your 12s go away, right? All right, so that's when you just multiply, or you simplify your denominator or your numerator first and then divide. You good, Sam? All right, now the other way to do it is actually the way that I would go about it because it's a little bit faster. All right, so you want to look at all the fractions that you have, and you want to look at what's the common denominator between all three of them? 12, right? So what I want to do is I'm going to multiply on the top and the bottom by 12. Okay? So when I do that, when I do 5 over 12 times 12, I get just 5, right? Now, on the bottom, you're going to take 2/3, and you're going to multiply it by 12. And what do you get there? Right? The 3 makes this a 4. 2 times 4 is 8. I'm sorry? Yeah, right? So if you do 2/3 times 12, right, the 3 turns this into a 4. Right? Because 3 goes into 12 4 times. Right. Yeah, you are. You're multiplying this by 12, and you're multiplying this by 12. Plus 3, right? And that gives you 5/11, which is what we got in the other answer. Right? So, again, you can do either way. I'm going to probably show you this way when we do the algebra problems, because I think it's a little bit faster. But you're more than welcome to do the other way as well. All right, so that's the first way was simplifying. The second way, that's when you multiply by your least common denominator. Okay, so, excuse me. 2/x plus x/4 divided by x plus 1 over x. So, based off of that, what would my common denominator be between all three fractions that I have? 4x, right? So I'm going to multiply the top. So if I wanted to put both of these together, right, I'd have to multiply this by 4, I'd have to multiply that by x. And then same thing here. This has a denominator of x, I'd have to multiply it by 4 so that it's the same. Okay, so if I multiply 2/x times 4x, what do you get? You get 8, good. Right? 2 times 4x is 8x. 8x over x is just 8. Goes away. That's the idea of multiplying by common denominator, is that it cancels out the denominator. And then if I multiply x/4 times 4x, what do you get? You just get x squared, right? x/4 times 4x. Right? You get 4x squared over 4. Right? And just 4's cross out, and you're just left with the x squared. We haven't done that yet. We haven't gotten there yet. We're still just doing the top. Here? Yeah. All right, now we're going to do the bottom, right? So you got 4x times x plus 1 over x. So you have 4x times x plus 1 over x. And what does that simplify to? Well, what cancels out? The x's go away, right? And you're left with 4 times x plus 1, which is, right, 4x plus 4. Okay. Can I do anything with that? Alright, so what would x not be able to equal? 0, right, from the original. -1. If you plug in, right, yeah, right. Yep, right here and here. -4. You're saying right here? It's just it's just saying that x can't equal. So like I can put a -4 in for there and there, and I'm still gonna get a number. Like numbers are okay. Like that's okay. You just don't want 0 here or there. Right? I don't think so. You do 4x plus 4 equals 0. Yeah, you get x equals -1. All right. What would my common denominator be? And x, right? Okay, so when you do 5 over x plus 4 times x plus 4, what cancels out? X plus 4, right? And you're left with 5x, good. Sure. So you have 5 over x plus 4 times x plus 4. Right? And that's really over 1. So that and that cancels. Right? So you just have now 5x. All right, now if you do 1 over x plus 4 times x plus 4, we'll cancel that again. Right? And you're left with just x. Right? So you got 1 over x plus 4 times x plus 4. Right? That cancels that. And then if I do 2 over x times x plus 4, what do you get? The x's will cancel out and you'll be left with 2 times x plus 4. Okay, so what can I do? I got 5x over 3x plus 8. Can I do anything with that? All right, so what can x not equal? 0. What else? -4. What else? -8/3. Good. So if you set this denominator here equal to 0, you get -8/3. You. All right, so see if you guys can come up with the answers for C and D.